Hi friends, in this video we are going to solve the same system of equation with the help of Gauss Siedal iterative method. So here in Gauss Jacobi iterative method, so here in the both the method, first we have to check whether the given system is diagonally dominant or not. So here this system is diagonally dominant. Here I will write here. Here system is here answer. System is diagonally dominant as this absolute value of mod of a11, that is mod of 10, is strictly greater than a12 plus a13 plus a1. So here absolute value of mod of a22, that is 10, is strictly greater than a21 plus a23, and absolute value of mod of a33 strictly greater than a31 plus a32, that is mod of 2 plus mod of 2. Here you can see here, so mod of 10 is 10, this 10 is greater than 2. Here this mod of 10 is 10, this mod of 10 is 10. 2 plus 1 strictly greater than 3, and this is 10 strictly greater than 2 plus 2, 4. So our given system is diagonally dominant. Now second step is rewrite the given system in terms of x1, x2 and x3. So here with equation 1, that is my equation 1, here I will write. So this is whole system. So in terms of x1, here I will write here x1 equal to 1 by 10 times here 12 minus x2 minus x3. So now in terms of x2, I will write with the help of this equation 2 here 1 by 10 13 minus 2 times x1 minus x3, and with the help of equation 3 here I am writing x3 as 1 by 10 times here 14 minus 2 times x1 minus 2 times x2. So here I will give this as, let's say, so this is whole system. Here I will give this as A, this is B, and this is, let's say, C. Now start with initial guess. Start initial guess as start initial guess as x1 at 0 is 0, x2 at 0 is 0, and x3 at 0 is 0. This is my initial guess. Now I want to find x1 at 1. So here this is, here I will explain, this is x1 at 0, x2 at 0 and x3 at 0 is my initial guess. So while finding x1 at 1, I want to find x1 at 1. At that time, here I am using x2 at 0 and x3 at 0. I don't have any choice, other choice. x2 at 0 and x3 at 0 corresponding to equation 1. So with this I get x1 at 1. Now I want to find x2 at 1. So at this time, so x2 at 1, here I am using x1 at 1 and x3 at 0. x1 at 1, comma x3 at 0. With this I am getting x2 at 1. So here x1, while finding x1 at 1, here I am using x2 at 0 and x3 at 0. So while finding x1 at 1, x2 at 1, so instead of x1 at 0, here I am using x1 at 1, which is found from previous step. So here x1 at 1 and x3 at 0. So now I want to find x3 at 1. So at that time, instead of this x1 at 0 and x2 at 0, here I am using x1 at 1 and x2 at 1. That is x1 at 1 and x2 at 1. So this is my x3 at 1. So this combinedly, this is my iteration first. Now here x1 at 1, x2 at 1 and x3 at 1. Here I got. This is my iteration 1. So this is my iteration 1. Now I want to find x1 at 2, second iteration. So at that time here I am using, I want to find x1 at 2, that is second iteration of the unknown x1. At that time here I am using x2 at 1 comma x3 at 1. I don't have any checks other than this. So here with this I am getting x1 at 2. Now while finding x2 at 2, so instead of this x1 at 1, here I am using x1 at 2, x1 at 2 and x3 at 1. So with this step I am getting x1 at x2 at 2. Now while finding x3 at 2, so instead of this x1 at 1 and x1 at 2, here I am using this 2. That is x1 at 2 and x2 at 2. So with this I am getting x3 at 2. So this is whole is my iteration 2. So with this, so that is here x1 at 1, sorry x1 at 2, x2 at 2 and x3 at 2. So this is my second iteration 2. Now in the same way I want to find x1 at 3. So at that time I will use this. So x2 at 2 comma x3 at 2. So with this I get x1 at 3. So while finding x2 at 3, here I am using this x1 at 3 and x3 at 3. So with this I am getting x2 at 3. So while finding x3 at 3, here I am using this 2, x1 at 3 comma x2 at 3. So in this way you can go for 4th 5. So while finding 0 iteration, here I am using, here this is my 0th iteration. So initial start x1 at 0, x2 at 0, x3 at 0. While finding x1 at 1, here I am using x2 at 0, x3 at 0. So with this I am getting x1 at 1. While finding x2 at 1, I am using x1 at 1 and this x3 at 0. So while finding x3 at 1, instead of this 2, here I am using this 2. So in the same way, this is my first iteration. While finding x1 at 2, here I am using this 2. While finding, so with this I am getting x1 at 2. While finding x2 at 2, here I am using x1 at 2 and x3 at 0. And while finding x3 at 2, here I am using this x1 at 1 and x2 at 2. So this is my iteration 2. So while finding x1 at 3, here I am using x2 at 2 and x3 at 2. So with this I am getting x1 at 3. So while finding x2 at 3, here I am using x1 at 3 and x1 at 3 and x3 at, so this is x3 at 2. So while finding x3 at 2, here I am using x1 at 3 and x2 at 3. This is the procedure. So here in this problem I will use the same method. So here this is my 0th iteration. Now I want to find first iteration. Here I will use x1 at, I want to find x1 at 1. At that time I will use x2 at 0 and x3 at 0. Here I will put this value in my A. So here I want to put x2 at 0 comma x3 at 0 in A. We get here x1 at 1. So I want to find x1 at 1 by 10 times 12 minus, here that is x2 at 0 minus x3 at 0. So which is equal to 1 by 10 times, here 12 minus x2 at 0 is 0, x3 at 0 is 0, which is equal to here 12 by 10, which is equal to 1.2. So this is my first iteration corresponding to unknown x1. So here with this step I get x1 at 1, which is 1.2. Now put x1 at 1 is equal to 1.2 and x3 at 0 in B. So here I am writing put x1 at 1 which is equal to 1.2 and x3 at 0 in B, we get x2 at 1 as, here I will write here, x2 at 1 which is equal to 1 by 10 times here 13 minus here 2 times x1 at 1 minus x3 at 0 which is equal to 1 by 10 times here 13 minus here 2 into 1.2, that is x1 at 1 here 1.2 minus 0 which is equal to here 1 by 10 times, here I will write 13 minus 2.4 here which is equal to, I will write here only 13 minus 2.4 here 601, that is 1.06 divided by 10 which is equal to 1.06, so which is equal to 1.06, the total answer. Now, so this is my x2 at 1. Now I want to find x3 at 1. This is put x1 at 1 which is equal to 1.2 and x2 at 1 which is equal to 1.06 in C. We get x3 at 1 as here I will write here x3 at 1 which is equal to 1 by 10 times here 14 minus here 2 times x1 at 1 minus 2 times x2 at 1. Now just calculate the part here 1 by 10 times here 14 minus 2 times x1 at 1 is 1.2 and minus 2 times x2 at 1 is, that is 1.06. So here just calculate first, this is 2.4 and this is 2, 1 and 2. So here 2.12, here just add 2.4. So 2, 5 and 4, 4.52. So 4.52, 14, 4.52. So minus here this is 8, 9, 4. This is 3, 13 minus 4, that is 9.48. 9.48 whole divided by 10 which is equal to 0.948. So here we just calculate this value which is equal to 0.948. So this is my x3 at 1. So here I got therefore x1 at 1 comma x2 at 1 comma x3 at 1 comma which is equal to x1 at 1 is 1.2, 1.06 and here this is 0.948. This is my first iteration corresponding to x1, x2 and x3. Now I want to find x1 at 2. So I want to find iteration 2. So here iteration 2. I want to find iteration 2. In this here I will use x1 at 2, which is at that time I will use x2 at 1 and x3 at 1, which is equal to 1 by 10 times here 12 minus x2 at 1 and x3 at 1. Just now put this value 1 by 10 times here 12 minus x2 at 1 is, here x2 at 1 is, that is 1.06 minus x3 at 1 is 0.948. So here, so you can calculate this as 1.06. This is 0. You can write here 0.948. So here both are minus 8, 0, 0, this is 2.008 whole divided by 2.008. So 2.008, now I will write here 1 by 10 times here 12 minus here 2.008. So here after that I want to subtract this 2.008 from 12, that is 12. So here I want to subtract, that is here we can take 10 to 9. This is 11 minus 2 is 9. So this is third point. After that divide this by here 10. So which is equal to 0.9992. So here I got this answer as 0.9992. So this is my second iteration corresponding to the unknown x1. Now find x. Now put I want to find put x1 at 2 and x3 at 1 in B, that is in C. In B we get x2 at 2 as here, that is x2 at 2, which is equal to 1 by 10 times here 13 minus 2 times x1 at 2 minus x3 at, that is 1 here, which is equal to 1 by 10 times here 13 minus 2 into, so here x1 at 2, here where is that x1 at 2, 0.9992 minus x3 at 1 is here, x3 at 1 is here 0.948. So here now I will calculate here, this is 2 into this, that is I will write here with minus n, 4, 8, 9, 19. So after 4 decimal 1.9984, that is 1.9984. This is 0.948. Let's say this is 0. Now this is subtraction. 4, 6, 4, 1. This is 2. So here this is after 4 digit. 2.9464. This is I will write here 1 by 10 times here 13 minus 2.9464. So here after that just subtract these things from 13 here 13. So just subtract this from 13. So what you will get 6, 3, 5, 0. This is 12, 10. So here 12 minus 2, 10. So after that divide this whole term by 10, which is equal to 1.0053. So here which is equal to 1.0053. So here this is my x2 at 2. So now find put x1 at 2 and x2 at 2 in this C. We get x3 at 2 as, here I will write x3 at 2, which is equal to 1 by 10 times here 14 minus 2 times x1 at 2 minus 2 times x2 at 2. Just put this value 1 by 10 times here 14 minus 2 times x1 at 2 is x1 at 2, that is 0.9992 minus 2 times x2 at 2, that is this 1.0053. So here we just calculate this value. Here I will write 1 by 10 times here 14 minus 2 times this. Here this is 4, 8, 1, 9, 1 and 19. So 1.9984. So here 4. So here this is 1 point. So minus. So this is 6 0. This is 1 and this is 0. This is 2. So here you can calculate after 4 digit. This is 6 10 0 0 1 and this is 0 and 2. So now here with this, so here just you can 1 by 10 times 14 minus here the subtraction 6 and 4, this is 0. I will write 8. So third is 9 plus 1 10, 0 1 0 1 2 plus 1 3, this is 4. So this is 4.0080. So you can here, so you will get here, just find 14 minus 0. This is 4 times here 0 0 8 0. So here subtraction 0. This is 2. So here this is 9. So this is also 9. Here this is 13 minus 4. That is 9. So whole divided by 10 again, which is equal to 0.9992. So here which is equal to, here I will write here 0.9992. So here this is my third iteration. So x2 at, sorry, this is my second iteration, x3 at 2. Now in the same way you can calculate x1 at 3, x1 at 3, x2 at 3 and x3 at 3. So here, so while finding, here I will write, I don't have space. So here I will write, so this is my x1 at 2 and x2 at 2 and x3 at 2. So which is equal to, so this. So this is my second equation. So here, so while finding x1 at 3, so you can use here x1 at 3. So at that time I will use this x2 at 2 and x3 at 3. So here I am not calculating this value. So here I got x1 at 3 is, here you can calculate at home. Here I got this value as 1.00 and x2 at 3, here x2 at 3 is again 1.00 and x3 at 3 also 1.00. So here you can calculate at home. So here, so this is the approximate answer. So you can observe one thing. So at 0th equation, here this is my 1.2, x1 at 1, x2 at 1, x3 at 1. This is approximately equal to 1. This is approximately equal to 1 and this is also approximately equal to 1. So after in the second iteration also, x1 at 2 is, that is 0.9992. This is also approximately equal to 1. So and from here this is x2 at 2 and this is x3 at 2. This is my x3 at 2. So this is also approximately equal to 1. So here in x1 at 3 you will get 1, 1 and 1. So here therefore the approximate solution of my system is x1 x1 which is approximately equal to 1, x2 which is approximately equal to 1, and x3 which is also approximately equal to 1. So this is the solution of my system of equation. So in this way we can find for any system of equation solution of any system of equation by Gauss Siedal iterative method. Thank you.